Hello and welcome to this tutorial. This is Casey and I'll start a small series or short series of partial fractions. And first of all, I want to do this introduction by explaining what partial fractions are, and they are actually very useful when you start using them to solve integral calculus, that is calculus 2. So you have to be very keen on how you solve this, and at times it requires extra efforts, especially if it's an improper fraction. You have to do additional step before you go into partial fractions. But before complicating it with a lot of narratives, let me go directly and simplify it to show you, first of all, what does it entail us to do. Suppose we have y over 3 plus x over 5. If we were to add this fraction, we have to get a common denominator, which is 15, and then we multiply by 15 both sides, okay, to eliminate this fraction. So here we get 5 and here we get 3. So what we have here is 5y plus 3x. And what fractional decomposition requires us to do is to convert back this fraction here into smaller chunks like the one on the left side of the equation. So ideally we are doing the reverse of what I've done right now. And then when you go into your calculus 2, you are able to solve the smaller ones as compared to this. So let's go ahead and quickly do an example. Suppose we have x, okay, over x plus x minus 4. Okay, what we have to do for this equation is we have to equate the left side, which I will show. This is now the left side that I'm showing you now. What we have to do is that these are factors. But now on the right hand side, we have to assign the numerator with a constant, a, b, c, or d, depending on the number of denominators that you'll have. So in our case, we have a over, the first factor is x plus 1, and the second factor is b, and we have x minus 4. Right? In the next step, we have to do away with the denominator by multiplying with the denominator for this fraction. We have to do x plus 1, x minus 4. Then we have x plus 1, x plus 1, x minus 4, x plus 1, x minus 4. So all we have to do now is to cancel out. This goes with that, this goes with that. This goes with this. On the last one, we get it this way. So the final output for this is x equals to a in brackets x minus 4 plus b x plus 1. Now, before we proceed further, because I know your textbook says do expand the brackets and collect like terms, but in my case, sometimes it can be very complicated. It can lead into very complex fraction. And before you do this, I would recommend, first of all, analyze the equation that you have. Now, let me just tell you what we can do here. If I say x is equals to 4, that means I'll get rid of a, the value of a, and solve for b. Following that value, we have 4 is equals to a. Let me just write it. 4 minus 4 plus b, 4 plus 1. Right? Let's do the cancellation here. This goes. Okay. Now, our equation will become 4 is equals to 4 plus 1 is equals to 5. So hence we have 5b. Therefore, b is equals to 4 over 5. Right? Now, we've solved for b. Let's go back again, eliminate b, and solve for a. How are we going to do this? What we do here is we give x is equals to negative 1. So we have negative 1 equals to a in brackets negative 1 minus 4 plus b negative 1 plus 1. Cool. So what do? We cancel out this and we solve for the remainder, which is -1 is equals to -5a. That is -1 minus 4 is equals to -5. Therefore, a is equals to 1/5. That's solved. Let me just give it the right color for the solution. The next thing we do is now applying the variables where we have variable a and variable b. So the solution to this is that a is equals to 1/5 divided by x plus 1 plus b is equals to 4/5 divided by x minus 4. Simplifying it, we have 5 x plus 1 plus 4/5 x minus 4. And this is our answer. So if you work it out backwards and come back to x is equals to x plus 1, x minus 4. And that's the end of my tutorial. Thank you.